Hello, and welcome to the new in Qt 6.10 Feature Updates webinar. My name is Ben Hadra, and I'm joined by my colleague Adam Keene. And today we're going to be talking about some notable features that are coming in Qt 6.10. If there are any questions throughout the presentation, feel free to leave them in the chat, and we'll be sure to answer those questions at the end of today's webinar. So with that, we can go ahead and get started. So here we've got a little agenda for us. We've split this webinar into three main sections. First, talking about some data integration updates, then talk about some ways to improve your UI development, and then finally talking about ways to keep your product modern. So with that, we can jump right into our first topic, talking about data integration. So again, we've got a little bit of an agenda here for this section. We're going to be talking about the new tree model QML type, the sort filter proxy model QML type, the QRange model type, and then finally the Synchronizer QML type. So let's jump into the tree model. So prior to Qt 6.10, tree models all had to be constructed using the QAbstractItem model using a C++ backend. So this typically made tree models relatively complex to implement because of the dependency on C++ and because this often required a separate class to handle tree items. So starting in 6.10, there is now the tree model QML type, which allows for the tree model / tree view pairs to be constructed entirely in QML without needing to necessarily have a dependence on C++. So our hope is that this leads to some faster and easier construction of views of this type, and the QML implementation is much more straightforward and requires significantly less code to achieve the same result as when you had to have the C++ dependency. So here we see a bit of an image of what a tree model looks like. So this is the more complex of the model types due to the parent-child structure of tree models, and therefore this is a little bit more complicated than the list model and table model counterparts, which already have QML types associated with them. So all right, so the tree model QML type. So tree models store JavaScript / JSON objects as data for the tree model. The tree model is intended to be used with a tree view. And this is going to use table model column types to define columns of the tree model. So notably, these are table model columns, not tree model columns. So it does still have a dependence on the table model itself. And each of these table model columns will represent a column of the tree model. And tree models can have any number of table model columns, as is logical for your tree model, and these are going to be used to define roles contained within the tree model using simple key value pairs. It is notable that table model columns only support the built-in roles used in Qt, which I've actually listed out right here. So these are all the different roles that you have access to when creating a table model column. And then we also have a kind of small example here, kind of just showing you the structure of how you would create a table model column as a child of a tree model. And then you can see here we've got this table model column is using the display role and giving it of name. So all right, so now that we understand table model columns, let's take a look at the actual tree model type itself. So the QML tree model uses the row property to add entries to the model. Now each row is going to represent a single node of the tree model, and any number of rows can be added to a tree model. So you can have any number of nodes associated with a tree model, and therefore any number of rows in your model itself. In a row, as it is a tree, a row can have additional rows inside it representing child items of an individual node, and therefore you can have a complex parent-child hierarchy inside of your tree model. So when this is done, that row will be added to the next layer of the tree model, and therefore you can form a tree. So we see this kind of in this example here where I've got a row property here, and that row property is using its own row property to create a child node of it, and subsequently thereon, we can create a complex tree in this fashion. And rows are used to define values for the roles defined in the table model column. So for example, here we can see we've got two table model columns, both of which are using the display role and have the name and price. And then inside of the rows there, we give the name role a value, in this case of fruit, and the price in this case has no value. But as we go down the tree, we can see we do eventually provide a value for the price role. So if we go ahead and flip this code over, we can actually see what this looks like in implementation, where we've got our food item and price as table model columns. And if we drop down the tree, we can see we're able to reveal the child nodes of fruit, vegetable, and meat. And dropping it down even further, we can actually get the actual entries, in this case, blueberries and strawberries. And we can see we also provide a price for them once we hit a logical point in the tree model where price becomes relevant. And as we expand further, we can see we can store large amounts of data in this tree model, but we can easily collapse this to make it much more easy to understand and view as the user. And again, this is fully implemented in QML, where prior to 6.10, this had to have some C++ backend in order for this to function. So a little bit more about the tree model QML type. Tree models, of course, have several functions for modifying data at runtime. So we've got functions like append row, remove row, set data, and set row, which can be used to actually modify the data inside of the model at runtime. So this allows you to make modifications inside of the tree view and have it subsequently make modifications to the tree model itself. So as we can see right here, we've got this table view.onCommit. So we're inside of the table view in this function. And then we're using the tree model's set data function to actually modify the data from the view. And this will modify the data as it's stored inside of the tree model, as well as displaying the updated value in the tree view. So if I go ahead again and flip this over, we can see that exact same tree model we saw before. And if I drop this down here a little bit and go to the blueberries entry, I could double click here and go ahead and modify, for example, the price of my blueberries. Let's say make it $2.99 rather than $3.99, and we can update the strawberries as well. Let's say make it $2.59 instead of $2.99. So lowering the prices a little bit there, and we can see we're able to easily update the values contained within our tree model directly from our tree view, as can be seen there. So we've got some nice runtime modification of our tree model, as well as being able to display the tree model. And again, all of this can be done entirely from QML without needing the C++ backend. All right, and that pretty much covers the tree model. So now we're going to move on to the new sort filter proxy model QML type. So similar to the tree model, this is intended to flesh out the model view framework within QML itself. So the Q sort filter proxy model does exist as a C++ class, but in order to do filtering and sorting, you did have to, again, have this C++ dependence prior to 6.10. Where in 6.10, you no longer require a C+ model to perform sorting and filtering, thanks to the sort filter proxy model QML type. So again, our hope is that this makes creating sortable and filterable models directly in QML a little bit easier. It does require a source model similar to the C++ counterpart, where you set this through the model property of the sort filter proxy model. And then the sort filter proxy model will apply sorts and filters to that source model, but it will not modify the model itself. So you can maintain a constant state of your source model while displaying to the user a filtered or sorted version of that model through this proxy model. Now, filtering can be handled through a function filter using the filters property of the sort filter proxy model, and sorting is handled through the role sorter, or by setting a role sorter to the sorters property of the sort filter proxy model. And then sorts and filters can be reevaluated using the invalidate and invalidate sorter functions. And these do need to be explicitly called in order to update sorts and filters. So when you call these functions, it will basically reevaluate sorts and filters you've applied. So if the user does go ahead and change their sort or filter, you'll need to explicitly call the invalidate functions in order to have them be reevaluated. This does not happen automatically. So let's take a little bit of a look at an example. So we can see here the function filter allows the user to define a method to define a filter, and this can take one argument to use to filter. And this is going to use the role data component to access the data from the model. As we can kind of see here, we have the filters property, and we have a function filter set to it. And this is passing a role data to it. And this is going to contain the defined data from your model. And then you can use that data to apply a filter to the model. And this does need to return a Boolean to define whether or not an item should be removed or not from the model. So basically, if you pass it false, or if this function returns false, it will remove the specified item from the model. And if it returns true, it'll keep that item inside of the model. And we can see here, in this example, we're filtering, we have an example where we have a list of employees, and we're going to be filtering based on the department that employee belongs to. And then we also can see we have the role sorters through a role sorter set to the sorters property. And this allows the user to sort based on some role name defined. So again, we have a role name of age. This is that same example where we have a list of employees, and this allows us to apply a sort to the age of the employees. And in this case, we have it set to a sort order in descending order. So the oldest employee would appear at the top and the youngest would appear at the bottom. And we can, of course, change this to ascending order if we wanted the inverse. So let's go ahead and flip this over, and we can see that example we have where we have a list of employees. And we can go ahead and filter on the department right here by entering it in this text edit. So if I enter the department HR and press enter. We can see we are filtering out successfully all employees that do not belong to HR. And I can go ahead and close that out and press enter, and it will invalidate the filter. And then we have our original list model displayed here. And I could go ahead and change this to marketing, press enter, and we can see we're filtering out again all employees that do not belong to the marketing department. Let's go ahead and invalidate that filter. And up here, we've got this switch here, which allows us to sort it by age. So if I flip that switch to on, we'll see our list changes here a little bit, and we are now sorting in descending order the employees' ages. So we can see it's starting at age 63 all the way down to age 23, and these are successfully sorted, again, in order of age. And then also, nicely, we can apply both a sort and a filter. So if I then go ahead and apply filter on HR, we can see we maintained that sort that we had there where we're still in descending order while still applying the filter. And I can, of course, go ahead and invalidate that sort as well. And then we'll have kind of our original model's order with the filter still applied. So we're by no means restricted to only having a filter or a sort enabled at one time. We can have both applied at the same time. And again, this is all done in strictly QML, so no C++ was required to generate this sorting and filtering functionality you see here. So hopefully this makes it a little bit easier to apply sorts and filters when working in Qt Quick applications. All right, so the next type we're going to talk about is the QRange model. So the QRange model is a bit different from the models we've talked about so far, where it is strictly a C++ type, but it basically allows you to make any of the C++ types from the standard template library much easier to quickly display in a Qt Quick or Qt Widgets view. So the QRange model can make any sequentially iterable C++ data type available to the model view framework. So what this means is the data source can be any C++ type which has the standard begin and standard end implemented. And this would be things like standard arrays or standard vectors. Will then be easily allow you to create a model and a view based on these types and easily display them in a view in Qt Quick or in Qt Widgets. So this does hopefully decrease the reliance on subclassing a QAbstractItem model, where normally if you had some data stored in, for example, a standard array, you would have to create a subclass of the QAbstractItem model and then organize the data inside of that array in the way that the abstract item model requires it in order to make it usable in a Qt Quick or Qt Widgets view. So what the QRange model does is it is designed to let the compiler generate that QAbstractItem model implementation based on the type of data it is constructed with. Now the QRange model is a subclass of the QAbstractItem model, so it is still using QAbstractItem model under the hood, but it basically generates it for you instead of requiring you to subclass it yourself. Although there are some notable differences when inheriting directly from QAbstractItem model versus using the QRange model, where modifying the data directly does not force the view to be updated. And this is due to the lack of notification signals in the standard C++ types, and the UI will not provide editing functionality. So things like set data and move rows will fail, as these are not implemented by default in the generated QAbstractItem model, although these editing functions can be implemented to work properly. So you are not restricted from creating these functions manually, but they are not going to be generated when you use the QRange model. So let's take a look at a small example here. So we've got a really simple example where I have a standard vector, which we can see right here, which is one of those sequentially iterable C++ types, where I've just got numbers 1 through 5 in a standard vector, and then I create a QRange model and pass the data from that vector to the constructor of the QRange model, and this will then generate the QAbstractItem model behind the scenes. And then I have a set initial properties, basically just to make the QRange model I created here accessible to QML, because I'm then going to display the QRange model in a QML application. So we can see here with 3 simple lines of code, we've made a standard vector accessible to a QML view, something that would take upwards of 30 to 40 lines and require you to subclass the QAbstractItem model prior to 6.10. Now this is of course relatively simple, so when we flip our code over, we can see actually in the actual example I have numbers 1 through 15, but the same kind of idea applies here. But we can see we're able to easily display that standard vector right here in a QML view, and in this case I've got a list view and a table view displayed here. So the QRange model is compatible both with a list view and a table view, and we can see that right here in what we've generated. And again, this is requiring far, far less code than would be otherwise required when subclassing the QAbstractItem model. So it makes it a little bit easier to create views of this kind when we have data stored in some of the standard types in C++. All right, so now moving on to our final topic in data integration, which is the synchronizer. So the synchronizer object binds properties, so a change to any synchronized property will update all other properties. So unlike a standard property binding, this is very similar to, the synchronizer works bidirectionally as opposed to working in a single direction. So this is going to be very useful when the direction of data flow is not predetermined and could happen from basically any property could become modified in your application. And you want to make sure that all properties that are bound to that property will be updated. So the synchronizer will make sure that always happens, where with standard property bindings, this is not necessarily the case. And we'll see a little example of kind of how that works in a moment here. Although it is possible for this functionality to be achieved using multiple signal handlers or multiple property bindings, the synchronizer is basically just intended to simplify this. So we found that using lots of signal handlers and property bindings just to get properties to stay in sync was relatively complex and could lead to some messy code. So the synchronizer is a way to just make it a little bit more readable. Now, it does require the Qt.labs.synchronizer module to be imported in order for it to be used. And it is also possible for synchronizations to fail, although we do have two signals which will be emitted if this does happen. So this won't be like unknown if it does happen. So the value ignored signal will be emitted when the property of the object did not respond to an attempt to set its value. And then the value bounced signal will be emitted if the property of the object refused to set its value. So if for whatever reason the synchronizer fails, there are some signals to notify you of this happening. So let's take a look at an example here. So here we can see we've got a pretty simple example. We've got 4 sliders. The first 2 sliders are using some standard property bindings where we can see we've set a default value to the first slider, and then we bind the value of the second slider to the value of the first slider. So that would allow us to update the second slider's value based on the first one. And in the second 2 sliders, we're actually using the synchronizer type to synchronize those properties rather than using property bindings. So we can see in our synchronizer type, we're using the source object and source property. So the source object and source property, these are going to be basically the object to synchronize from. And then the target object and target property will be the object or the properties to synchronize to. The difference here is that the source object and property will use its initial value for the initial synchronization. So if there's a default value set to both of the sliders that we're synchronizing, it'll always take the initial value of the source object and property, and it'll essentially ignore the target object and target property. But then any updates that happen after the fact will always remain synchronized. So we just need a way to kind of get an initial value for our synchronized properties. So if I go ahead and flip this code over, we can kind of see how this works. So when we're using the standard property bindings, if I go ahead and modify the value of the first slider, we can see the second slider's value is updated to match the first slider's value. However, since this is a property binding, if I modify the value of the second slider, we can see we can easily get those properties out of sync with each other. Even though they're bound to each other, only the slider's 2 value is bound to slider 1, and therefore it can actually get out of sync if I modify its value independently of the first slider. Then, of course, if I modify the first slider again, they will go back into being in sync. However, I use the synchronizer. It doesn't matter which of these sliders I modify, they will always remain synchronized. So this gives us that bidirectional property binding, where now it doesn't matter where the flow of data is coming from. Those properties are always in sync, where if in the standard property binding section, if there is an unexpected flow of data, we have the ability to get out of sync, as can be seen there. All right, and that actually concludes the data integration section. So now I'll pass it over to Adam, who is going to talk about building UIs easier.
Thanks, Ben. The next section in the 6.10 feature update webinar is going to be in regards to building UIs easier. So there have been a few types introduced and updated in this section, and we've got an agenda laid out here for that. So first we'll cover a new type called FlexBoxLayout introduced, as well as vector animations, SearchField QML type, accessibility updates, and some updates to the Qt Graphs module. So first talking about FlexBoxLayout. So this is a new type introduced in Qt 6.10, and this is available in the Qt Quick Layouts module. So it has the ability to automatically reposition child components to fit inside of this layout. So it's going to generally behave like a grid, but with the additional ability to reposition those child components based on the available space. So similar to grid layout, row layout, and column layout that are available in the Qt Quick Layouts module, this Flexbox layout type will be available as well. And it has properties that are available in order to shift how those components are repositioned. So there's control over that behavior as well. The behavior is going to be similar to that of the CSS flexible box layout. And on the back end, it's going to use the Yoga engine to derive the geometry of these flex items. So in regards to some of those properties and enumerations that are available to control some of this behavior, we've got a list here of some of those functionalities here. So we can align the content, which specifies the distribution of flex lines. We can also align items, define the direction of the item layout within the flex box, define the gap, which is going to be the amount of space between these items, whether it's a row gap or a column gap. We can justify content, and we can wrap the content accordingly. So you can see an example here on the right side. We've defined some of those enumerations, or defined some of those properties with those enumerations. And if I flip the example over, we can see we've got a basic Flexbox layout where we have a set of rectangles within this Flexbox layout. And with some controls on the left side, we can see if we modify the height and width of this Flexbox, the rectangle components will automatically be repositioned inside of that Flexbox layout. We can also do a few more things like control the gap between these items with this slider here and change the alignment and justification of these rectangles as well. And lastly, there is a switch that is able to change the direction of the layout. So that will cover Flexbox layout, which is a new type introduced in 6.10. And next, we'll talk about the SearchField QML type, which is also new as of 6.10. So the SearchField QML type is intended to be used to search for items within a list. So basically, it's an editable text line where you begin to type in within the search field. It's going to display a list of suggestions that you can choose from. It is important to note that although it is showing these suggestions, it doesn't automatically handle the filtering based on your entry. So in our example here, we'll pair it with a sort filter proxy model in order to flesh out the rest of that filtering behavior. But there are a few different properties here as well that are important for the search field. The first of which being the suggestion model. This defines the model which is used to populate the list of suggestions. So that will be what is displayed as you're typing within the search field. And then we've got a text role that can be used to define the role from the model that's going to be used to populate the suggestions, as well as pop-up and clear indicator. So if we flip this code to the other side, we can see our search field QML type there. We've got it on the top of this contact list where we can begin to type in within this search field, and we'll see the suggestion model, which is used to populate the list of the suggestions here. Again, the search field by itself doesn't handle the actual filtering, but it gives us the ability to select an entry, and then paired with the sort filter proxy model, we can see the behavior here. Great. Well, that will cover search field QML type. And the next set of updates is going to be in regards to vector animation. So the vector image type has some updated support in Qt 6.10. The main ones being that this now has the ability to support animations that are parsed by Qt SVG and the SVG to QML tool. There's also the ability to support Lottie files. And there are a few notes here with the Lottie animation support. The first of which being that there are some updates to the API, including the ability to indicate a source file as a trusted source file. So that's something that will be required in order to properly display the Qt Lottie animation. So worth noting that in 6.10.0, there's limited functionality, which we'll display in a second, but I would keep an eye out for the upcoming minor release, 6.10.1, where the full functionality is expected to be released. I just talked about that new API, which is used to control the animation behavior. We can see a few settings here that we can change, like the loop count, basically the number of times that an animation will repeat. And we could set this to infinite if we'd like. We can pause the animation with the animation stop paused control. And then that assume trusted source, which I was just talking about, allows the loading of these Lottie animations. So if we flip this code to the other side, we can see we have a vector image here, and we have the ability to open a Lottie file and display it. So this will be the Lottie file that is File Explorer here. We can open that, and we can see an animated rectangle with some basic functionality for displaying a Lottie animation. All right, so just another couple things on these Lottie animations. There's also a new tool called Lottie to QML, which is a tool that is available to convert Lottie files to Qt Quick Scenes. So very similar to the SVG to QML tool. This allows you developers to create QML-based animations, which are equivalent to their Lottie counterparts. So this is in technical preview in Qt 6.10, and we can see on the right here a result of a Lottie to QML conversion, essentially. So here we've created a parallel animation with a couple of property animations within it. That's the result of running this Lottie to QML tool. There's a bit of additional support for animating solid, null, and pre-composition layers as well. And if we flip this example over, we can see this resulting Lottie animation as a Qt Quick Scene. So we've got just a basic animation here again, but this is converted to a purely QML scene, QML component, Qt Quick Scene. So we're able to create an animation from a Lottie file. All right, next is accessibility updates. So there are QML styles which have been updated to interact better with contrast accessibility settings. So these settings on your platform, whether it's Windows, Linux, or so on, adjust the colors on a system to increase contrast. So the QML styles have been updated to adjust their default coloring to kind of account for these accessibility settings when they are enabled. In addition to that, the default widget styling has also been updated to match these accessibility settings as well. So these updates have been applied to the basic, Fusion, and Fluent Win UI 3 QML styles. And we can see here the basic and Fusion styles are going to use simple colors, whereas the Fluent Win UI 3 will try to match the theme. So let's see this in action. If we flip this example here, we can see a basic example with a few controls. As we interact with this example, we can see some of the light coloring in the background and the blue color on these switches and checkboxes, which are kind of our default contrast accessibility settings. So this is running on Windows. So if we actually go to our Windows settings and apply an update to these contrast accessibility settings, we'll set this to aquatic instead. We can see here that our Windows accessibility settings have changed, which we saw in the settings menu there, and as well as our application here the color scheme has changed in order to account for those accessibility settings. We can see a darker background and some darker or more contrasting colors within the actual application. So we can go ahead and set this back at this point. And we'll keep moving on. The last update in our Build UIs Easier section of the webinar is going to be in regards to Qt Graphs. As a reminder, Qt Graphs was introduced in Qt 6.6 as a replacement module for the data visualization module and Qt Graphs. So essentially, these modules are deprecated now, data visualization and Qt Charts, and Qt Graphs is going to continue to receive updates. So some of those updates in 6.10 are the new draw mode, which has been added to 3D surface graphs. So there's a new draw mode called Draw Filled Surface, which allows you to fill the space in between the bottom plane of the graph and the actual surface. So we'll see this in the example in a moment. We've also got multi-axis support for 2D graphs and a couple of new 3D node types. So there's bars 3D node, scatter 3D node, and surface 3D node, which basically allow for these 3D graphs to be displayed directly within a View 3D scene. So we can see an example of that in the code. Actually, on the right-hand side, we've got a scatter 3D node implemented there with the scatter 3D series. But if we flip this example over, we'll walk through these three kind of modifications. The first being the surface graph. So we can see this new draw mode applied. We've got a few different options in this combo box in the top left here. By default, the draw mode is going to be surface. We have a couple different options like wireframe we can apply, which is going to just display the wireframe example there. Surface plus wireframe. And then another type, which is going to essentially draw this filled surface where we can see the actual space between the bottom plane and the graph, bottom plane of the graph and the surface filled. So that's kind of the new draw mode for 3D surface graphs. We can also take a look at our 2D graphs. So we've got a line graph here with the multi-axis support. So we can see there are two y-axes there, one for temperature and one for rainfall. Just an example of a 2D graph that has the multi-axis support. And then lastly, we have a 3D view, which has a scatter 3D node within that 3D view directly implemented. So we have a 3D graph implemented within a 3D view. And that will cover our Qt graphs updates, and we'll conclude our build UIs easier section. I will pass this back to Ben.
Great, thank you, Adam. So the final topic we're going to talk about in today's webinar is some topics about keeping your product modern. So mainly what we're going to be talking about are the embedded hardware updates and then updates to desktop and mobile platforms. So basically our updated support as we move forward with this new release. So first talking about some embedded hardware updates. So we have a new tier 3 hardware, which was actually done by TQC. This is going to be the Yocto Scarth support for the STM32MP157F. So some new tier 3 support there, which should be great for those using that hardware. Then we have some new hardware adaptations, which were done by third parties. Mainly these are going to be the Azurio Nitrogen 8M and a few different models of that. And then we have new Yocto 5.2 Walnuscar support for Boot to Qt. We have the upgraded Tier 2 support within Boot to Qt for the NXP IMX93. And then we've also actually downgraded to Tier 3 in Boot to Qt the Toradex Colibri IMX6. So hopefully this gives you a bit of an indication of kind of the direction we're going, where we're slowly phasing out the older IMX6 devices and we're phasing in the newer IMX93 devices. So you're kind of seeing the slow phasing out of older devices and the phasing in of new ones. But again, we don't want to do this kind of all at once. Let's not blindside people, but hopefully give you an indication of kind of the direction we're moving. And it is worth noting that none of this support is affected in our latest LTS, which is 6.8. This is only in effect as of 6.10, but hopefully it indicates where we're going for the next LTS, which will be 6.12. So that covers our embedded hardware updates, and now we're going to be talking about some desktop and mobile platforms, mainly just talking about upgrading or adding support for the newest releases of the various operating systems. So for Android, we've added support for Android 16, which brings Qt support from Android 9 through 16. We've also added some splash screen animation support. So when you have an animation applied to the startup of an Android application, this is now supported within Qt. And we've also got 16 kilobit page support as well. As far as iOS goes, we've added support for iOS 26, which brings the Qt support for iOS from 16 through 26. And we've also added some Apple Pencil support. For macOS, we've added support for macOS 26, which brings the macOS support from macOS 16 through 26, similar to iOS. And then Windows, we've actually not added any new support for the Windows operating system itself, as previous Qt releases did support Windows 11, but it's worth just highlighting we do currently support Windows 10 and Windows 11 in Qt 6.10, but we have added WebView 2 as a native backend in Qt WebView. And then Linux, we actually have no changes at this time for Qt 6.10. So essentially the main highlights here for this page is that we're adding support for the latest releases of all these operating systems, making sure that if you do have an application which is intending to use the latest releases of any of these operating systems, we are making sure in our latest releases of Qt to stay in line. All right, and that actually brings us to the conclusion of this webinar. So if there are any questions in the chat, we will take a look at that now and we'll try to answer them for you live.